do both. So it's important to understand about the technology and what's going on in the commercial marketplace and what we're implementing in the DoD enterprise stack, but we're not going to focus too much on the technology. Right? Let's just assume that the commercial marketplace has figured this out. If we're using all the tools of the software factory, the commercial marketplace, as long as we can make sure they're secure, then let's go ahead and use them. So that's not our problem, but let's look at it. Unfortunately, a lot of folks say, well, let's just go do what they do in the commercial marketplace, and that's the magic bullet, right? We'll just go do that. Let's do a cookie cutter. Let's lift it up and pop it over here. And as we discussed on Monday, it's really not like that. You got to sort of tailor it for your effort, what it is you're trying to do, the size of your organization. All this stuff sort of has to play in there and connect. And I would say if you start thinking about DevSecOps as a collection of technologies, okay, cool. That's a very important part of it. When we start talking about automate everything, test everything, secure everything, that's sort of that technology stack that we can employ that gives us those things. It's a combination of techniques. Continuous integration, continuous delivery or deployment, all these things are the techniques of getting capability quickly with velocity from left to right. So these are the words that we start using as we describe what it is we're trying to accomplish. And mindsets, right? This is the culture part of it. So if for the most part, if you're unable to understand that these three things are the blocks, then you're probably going to have a problem making the software factory and DevSecOps efficient and providing value. So if you can get these things work together and you get the kinks out of it, right, we're going to fail probably when we start, probably maybe in the middle, who knows when we're going to fail. But if you can get these to work together, the technologies, the techniques and mindsets, change this culture, you're probably going to increase velocity and basically delivering secure products, a quality product that's been thoroughly tested via automation and all the tools that are out there that you're going to be able to develop some pretty killer software that is more stable and better quality than what we've seen in the past. Okay, just simply by employing that. So there's a lot of tools that enable the software DevSecOps stack, and we'll talk. Well, I'll show you some of these tools. I don't really care if you remember any of them, right? You can just pick them up, say, hey, these are the tools of the software factory, fine. But as we start thinking about DevSecOps as skills, culture, and tools, okay, the skills of the people, the educated people within the government that understand this, the educated people and the skills of the contractors we're going to hire to do this type of work, that's a pretty important part of this. We've talked a little bit about the education challenges that we're having to make the government people aware and what type of changes have to happen. In the developer side of it, they have to have the skills to run a software factory and have the people involved. So, my assertion is the government can manage a software factory. The people that are going to do the work in the software factory is going to be the contractor. We're never going to have enough people in the government that's going to have the skills, military or civilian, that are going to have the skills to do the actual development work, the software coding. We can be the oversight, the acquisition managers, fine, that's what we do today, but we need to make a shift if we want to make this to happen and start pushing this down to, the mid-tier, the middle part of the defense industrial base, or maybe even the large contractors. So as you start looking at Lockheed Martin said, yeah, we want to do this, right? You've been holding us back. we have young, intelligent people that are going through school and getting all this education, and then we drop them into a waterfall development. It just so if they can make this shift, they can start challenging their people to do this. This is the Aegis $1.1 billion effort that Lockheed Martin is coordinating and working through to shift from a monolith to a microservice architecture, and also change the software development practices. So this is all sort of happening as we speak, right? The dust is still in the air. From an operations perspective, what do I get? Okay, as the user of this, the user of the software, what do I get? I get secure software. Okay, that's really important. I get reliable software that is pretty much defect free. Now, I'm not saying defect free. I say pretty much. You're never going to have 100%. You're not going to catch everything, right? Once you deploy it, once it gets out there and they're using it in their systems and that environment, then you may have a problem, right? That's that chaos engineering stuff and everything else that we're going to talk about. And scaling, being able to scale the software and not scale a monolith is really important. So, I get really excited when we start thinking about what Aegis and our combat systems are actually trying to do. One of them is track management and target management. And when you're highly saturated, dense, airborne environment, you're tracking a lot of stuff. And when you start entering into these small UAVs and smaller type of things that you may have hundreds of these coming in, a monolith isn't probably not going to be able to handle a very highly intensive track environment. If you change from a monolith to a microservice, then you just call up a track targeting application every time you want to designate one of these things, and you start calling up these little pieces of the container that basically works in there. So I think that gets really exciting when you're thinking about scalability of systems at the tactical edge as the environment is changing, as we're going to autonomous unmanned small systems. So anyway. So tools is an important part of this, and security. We did cybersecurity last week. We sort of touched on this, from defense in depth to zero trust, all these type of things that we're going to build in. And now we're going to sort of shift in a discussion. What can we build into the software that provides active security monitoring and can actually do things autonomously to protect the system? So that's the next level, right? We're sort of peeling this onion. If you feel like, it's like, oh my God, we're peeling another, that's what I'm doing. I'm peeling the onion. We're going to get to the core of what this is all about, but I'm sort of giving you a preview here. Is we can build software that can actively monitor itself, and when it sees something going bad, take action without the user involved in it. So it's pretty awesome stuff. But this is the next level of stuff, and this is what the user wants, right? You want software that works, that doesn't have the defects in it, that is secure, and if I need new capabilities or new features, I can get that within a short amount of time, not years. Okay, so it's an exciting time. I think we could all agree that this is pretty awesome stuff. So when we start looking at the principles of DevSecOps, what exactly are we concerned about, and what it is that we should be focusing on? One of them is collaboration. The traditional model of software development is one of silos, all right? Stovepipes, rice bowls, whatever term you want to use. And there's very little collaboration between the developer of the system, the testers of the system, the security people of the system, and the operators of the system. Very segmented, very rice bowl, very distinct type of functions. So that's sort of how we're set up, right? That waterfall methodology. If we start collaborating with each other and talking to each other about what we need, you started seeing that in the agile part of it, right? When we talked about agile and the user being involved with, hey, 5000.87 is the example, the software pathway. And they say basically the user has to tell what type of capabilities they need. They need to come with funding for it. We need to sort of set this up, and they need to be involved. They need to be engaged, and their engagement comes, and agile comes at the very end of the sprint, and right prior to the retrospective, as they're giving their opinion of what it is they've seen with working software. Right, that's collaboration. That's collaborations between the user community and the developer community. Right, so that's the start of this. But when we start talking about collaboration, we're talking about collaboration between inside teams and functions. So we're really talking about how do the security people, the developers, the coders, the operators even, how do they basically communicate with each other? And that's what we're going to be talking about. We start bringing up the concept of the lean process, of flow of value from left to right. We start thinking about what is it that prevents us from delivering capability in 1 hour? What prevents us from 24 hours? What prevents us from 48 hours? We'll talk a little bit about the ATO process, the authorization to operate process for IS systems, and the challenges we have with that. But I think that's sort of the thing that we're looking at is, if you want to go fast, and everybody says we need to go fast to add new capabilities at the tactical edge, then this is what we need to start thinking about. How do we lean this out? So it's really a lean event. It takes sort of the agile view of lean also. Empowerment, how do we empower the teams to make good decisions so they don't have to turn around and ask someone else and stop? And with accountability is also that part of it. And how do I get fast and continuous learning from the software factory? How do I learn what worked and what doesn't work? How do I continue to monitor the software to make sure that I understand the problems it's having, so I can learn from that and pull it left? The shift left concept, we've chatted a little bit about it. We talked about it from a RMF perspective, the security perspective, shifting that left and getting it into the process. But we look for opportunities to shift things from the end of the product and start working on it at the beginning of the process. So that, and I don't think it's anybody in this class. I think it was a DL student says this is a well overused term. I was like, all right, fine. We got to say something, so let's just say it. Collaboration tools. Look, anybody know or have any relationships with a software coder, a person or software engineer who actually codes software? You ever seen one of these people?
Yes.
How would you characterize them as far as their personality?
Introvert.
Introvert. Okay, describe what an introvert does.
Introvert does not like to be a social butterfly, so they'd rather not be social or around other people, stick to themselves.
Yeah, it's like a lot of people that won't come up on their video, right? They don't want to be seen. They're sort of like, it's like, hey, I can just watch this and not participate. He's not going to call on me, that type of stuff. Yeah, if you've ever done the Myers-Briggs type indicator, which is a really good tool to try to figure out what you are. I'm an INTJ, so I'm an introvert. You would know it. I'm a thinker. I am very judgmental. So we do these these Myers-Briggs types indicator, and I've done them over time, and I've sort of changed over time. First of all, I have to talk to you. I have to present to you. I have to come out. I'm a forced extrovert, is sort of what we call it. But when you look at the most software coders like to be, give me the task, leave me alone, I'm going to do this, and no. So I ran well, I was running a game company with my son after he left Microsoft. So it's software, right? And one of the guys that was working for us, Gary, really nice kid. My son knew him from high school. You know, they knew each other all through high school, and he went to go get a degree at at UCSD in software engineering, and he failed out because he could not handle the structure of courses and classes. But he was an extreme programmer. I mean, this guy is one of the smartest software coders I've ever seen. That he could learn anything and do stuff that was awesome, amazing. But he was painfully introverted. He is. I mean, he'd come to my house. They play whatever magic cards or whatever they play, that stuff. And he would come in the house and he would not look at me. He would not make eye contact and would not say anything. I was like, Gary, dude, you know us. Say hello, for God's sakes. Hello. And but and the reason I bring this up is you got to look at this culture of that we've let these software folks sort of like do their own thing and not communicate. Now we say, hey, communicate with each other, share ideas. If you have a problem, get on a collaboration tool and talk to each other and promote that. And one of the ones I seen them like a lot is Slack, is a software program that they are able to communicate very easily, transparently, and it pops up. So it's a pretty lightweight, good communication collaboration tool. Teams, well, the thing with Slack, there's no video. So that's sort of the power of it, is like, no, we don't want to look at each other. Let's just share information. So anybody use Teams in this class? It's better. It's actually a couple years ago, ITAX was looking at doing away with Zoom. It costs NPS $250,000 a year to have the license to use Zoom. And they're like, hey, we're getting Teams for free, government Teams. Well, why are we paying for Zoom, this platform? And it was pretty overwhelming that most people that were teaching DL and during COVID, they like this. It's easy to use, blah blah blah. And but Teams has evolved. I think that's it. It's not a bad environment, but this is what we're talking about. The ability for if someone is on a team and there's multiple teams of people working on this, that they're able to ask somebody for some help, or what do they think, or that type of stuff. So collaboration tools are really important to open up communications. The flow of value from left to right is the second principle of DevSecOps. Continuous integration and continuous delivery. This is the foundational part of DevSecOps. If you are not doing this, you're not doing DevSecOps. If you're not doing continuous integration and continuous delivery, or development, use delivery, development, interchangeable, just depends on who you are. We'll talk about that. This is fundamental. And so when we start thinking about the tools of actually automating this, and the dashboard in which project managers or program managers can say what's going on. If you look at DevSecOps compared to waterfall is like, what are we doing today? We're in the design, right? We're in the design phase. Okay, I know what we're doing. I can go look at people. When I start looking at DevSecOps, I was like, what are you guys doing? And they're like, we're working, and we're working on all these features. So it's like, oh, okay. I'm just going to go, let me go back to my office and I'll just press the I believe button that we're starting to deliver great software. But having tools that actually let us monitor what's going on in the software factory, and actually display to us what is happening. So I just pull out Jenkins. It's one of the tools that a project manager can use to observe what's happening in the CI/CD environment. What's going on? what software is proceeding along well, what software is having problems and failing back. So they'll give you a dashboard. I've seen it to where, they'll have like a little smiley face or like a frowny face or a cloud, a dark cloud over it, and then one with a little lightning bolt. That type of stuff does this. Ooh, maybe I need to go talk to somebody about this, right? This is real time measure. It's not metrics. It's measure of what the heck is going on, so I know what to talk to. So not only are these tools beneficial to the operations of the software factory, DevSecOps, it's also beneficial to the product manager or program manager. Okay, so this is when people look at. I'll show you later in the course. I'll show you what I'm really talking about as far as continuous everything. People are like, I don't know. I was like, no, we've got a bunch of tools. Don't worry, it'll make sense to you when you see it. So this is sort of where we're going on this. We start talking automation, a lot of automation, a lot of software tools that automate the processes, and this is very valuable. It's just like the quizzes I give you, right? If I give you a multiple choice, true or false, it's automated, right? You put in the right answer, you get full credit. You put in a wrong answer, you get zero credit. If you don't get all of the multiple choice, you get a mixed credit. When I put in the essay part of it, I got to grade that, right? There's no automation. That's manual. That's when the train comes off the track and I have to basically stop and I got to do that. The manual process. So it slows me down. It slows you down, but it slows me down a lot because I got to do 50 of these. You only got to do one. But that's what we're talking about. Automate the process, automate as much as you can. Look for tools to automate for security, for the CI/CD stuff. So this is what we're talking about. Having a tool stack that basically can say, don't worry about the tools themselves, the names and stuff. But I wanted to show this to you from a conceptual perspective. So let's look at the top. Let's look at the middle first. Okay. So source code. I'm developing the source code. This is what Gary does, right? Gary basically gets in there and he says, okay, we need to do these features, Gary and his team. They're in there and they're writing Fortran 77, right? Or they're doing Python or JavaScript, whatever language they're using. But that's the source code. And they basically, every night or whatever the periodicity, they have to basically send that source code into the continuous integration server. So if you think of it as I like to think of it every day, right? They come in, they check, they pull it out of the CI server, the continuous integration server. They pull it out and they work on it and they put it back in. And overnight, it basically these tools basically will run and work on the integration part of it and run security scans and everything on a continuous basis. And then the next day they come in. It's like, well, sometimes it's not going to work, right? The code's not done, but there's a good amount of code that's probably done, the source code that you can start looking at the security vulnerabilities, all this other stuff. So let's just go there. So here's the source code. Like I mentioned, the continuous integration server keeps control of versioning of the software. So there's only one version. It's the version that Gary checks out, and then at the end of the day, he checks it back in. There's no versioning control here. It is all together. A big deal in waterfall because you can get forking in that area. Test and scan. So once it's in the continuous integration environment, we're running test on it as far as did it compile correctly? Did it meet all the features? So these are all these tools that basically go in and they are doing security scans on it. Is there a vulnerability? Let's catch it now. Right? It's all within the development environment, right? This is not going out. Artifacts and ultimately get it into a state where it can deploy with a CD server. So there's an artifact. It's probably be more appropriate to have like a CD server here that's collecting everything and says, okay, we're ready to send it to deploy. So whenever they decide that they're going to push that software feature or capability to the user community, you have that deployment server, and then we're going to monitor software. So these are sort of similar, these type of tools that, here's Jenkins, here's Amazon Web Services. So this is sort of how it goes. So DevOps code, creating value and availability. So basically the code moving left or right. So we have to build in trust and confidence in the software. How do we do automated type of stuff? So there's a lot of automated software that you can run to make sure that you're creating secure software. It's looking for vulnerabilities, it's looking for defects. So this is a lot of the tools that basically you can use and run at these particular versions of where the software is. So early on in the source code area, basically you're running these automated tools. When it's in the CI server, when it's in test and scan, here are the tools for test and scan. So let's not get enamored by the names of the tools. Just believe that there are tools out there that provide enough depth and capability to do this, but we're doing it continuously through the software development process. It's pretty amazing when you think of how we used to do it before, right? We get it right out to this stage, and then we would go, let's go run some security scans. Let's go have somebody look and were you compliant in all this? It's like we're doing it all the way through. So this is as we were talking about the ATOs on Monday, and building confidence that our software factory and our DevSecOps is building secure code, and if it's low risk, we should be able to push it out without manual intervention. This is it, right? If I can convince them that these are all the tools of the DevSecOps environment, and they believe it, then they're like, oh, okay, this is probably about as good as you can get in a low risk environment to do continuous authorities to operate. This is why. Okay, that making sense a little bit? We said trust but verify, with the ATOs last time, but this is how we do this. And so if we can have a standard for DoD that basically said, here are the standard tools that are certified to be used in a DevSecOps environment for DoD, then who is to say as an ATO or as an authorizing official that they disagree with that, right? The DoD says this is how we do it. So this is the power of having our DoD CIO basically come out and say, yea, verily, we're going to use this tool set, this software capability to release software. And once the ATO folks, the AOs, authorizing officials, basically are on board with this, is like, okay, if it's low risk item, low risk change, then let's go ahead and push it out. Okay, that making sense? Connecting the dots. Okay. Empowerment. This is interesting. When we start saying we're going to give the software engineers more control over the application lifecycle, it basically is saying we're trusting them to do the right thing. We understand this in the military, right? You are empowered as a junior officer. You go out there and you go do that, and if you need help, you go ask the boss. You don't ask the boss every time you want to do something, right? You are empowered to lead and manage a division or a department or whatever the Army does, or I think Coast Guard does the same. But that's what we're talking about: empowering down and basically giving them all the tools and all the training they could possibly have in order to do the right thing without having to go ask for permission. Okay, so that's what we're talking about. So it's like, well, why wouldn't they do that all along? It's like, because we didn't trust Gary. Right, we didn't trust Gary to make these decisions because Gary's never been in a position to be empowered to do this. So this is the, we talked about that culture of blameless post-mortems. We talked about that psychological safety part of it. Now I'm saying, okay, now go do the right thing, Gary, but don't screw up. And right, we're going to be like, hey, it's going to happen. Gary's going to do something, but we're going to learn from this, right? We're going to hold them accountable for it and empower them with it. But we're going to change our way that we talk to them and don't blame, and don't come up with a list of corrective actions, that type of stuff. So it is a sort of a weird environment. Fast feedback and continuous learning. This is another principle of DevSecOps. Initially I'm going to give you the product, right? Think about minimum viable product, minimum viable capability release type of concepts. So minimum viable capability release, right? The features that is the minimum viable stuff that the user basically can say, I can start using this, right? And that's probably going to be a little bit of a heavyweight type of delivery, right? It's going to have a certain set of features, but the next thing I give them is not going to be another major release. I'm going to give them little stuff. I'm going to give them the next feature when it's ready. I'm going to send it out to you, right? I'm not going to give it to you, in small batches. Whenever it's ready, I'm going to put it out there rapidly, and stuff. So this is a culture problem that we have in the military, right? Our culture environment says protect the folks at the tactical edge, don't change anything. They've been trained to use this stuff and it works. Don't touch it. And now we're saying, I'm going to keep touching you at the tactical edge. Ooh, that sounded weird, but yeah. So that's what we're talking about. Pushing out capability, features that they want. We're going to have to support it, right? I'm not saying just throw it out there and good luck with it. We're going to have all of the documentation, the training if it's required, all these other things. Think about what if I can add a capability and the user really doesn't need to know about it, that it just does it. It's in the machine. It's in the software code. It actually does this and enhances something. Does the user need to know about it? Do they need to be trained? No, probably not. What if I'm correcting something that's not working exactly right? I just basically pull that chunk of application out and replace it with something that's working. Do they need to be trained? No. So that we gotta work our expectations. Once the users understand we can do this and we can and we're pretty much fail-proof in doing this, I think the culture will start changing. Right now it's in a protect, don't touch, and now we're going to be touching you a lot. So that's sort of where we're going. Okay. Once we can convince them that we're capable of doing this, right now they think we're a bunch of knuckleheads, right? But once we prove it and we're able to get this going, I need to convince them that I need to monitor and I need telemetry from the software programs, from the systems that are operating out there. Some sort of observability tool. I had a problem with that word yesterday. So yeah, it's critical for us in the software factory and DevSecOps to get this type of information from the code, from the software, to report back how it's doing. And it really does provide a lot of feedback stuff. You've seen this in system engineering type of stuff, right? The user sort of has an idea of what they want. It's going to take us a little bit to get to the ultimate thing, and they're going to learn too as they go through. Shift left, we've chatted about this in the security side of things, but it is a very important thing to think about. Other things. How do I? Last May, the DOT&E director, who's now the RDT&E for the Navy, he just got appointed a couple months ago, a month ago. But he was saying he's worried about the operational testers. As we start thinking about doing DevSecOps and continuous software delivery, he says, where's the operational testers on this? Today they're just like, well, give me the complete thing and I'll go see if it's suitable and effective and I'll give you a report back. It's like, well, we gotta shift that whole organization left too. How do how do we get things that are to identify first what is operational test what is their role in all of this, and so they know they have a challenge, and do operational testers now become part of the DevSecOps environment, the software factory? Do they basically become like an ATO organization, basically doing, I believe you that you're going to deliver great software, and occasionally we'll take a look at this based on the level of threat. Maybe that's when they get involved, right? When we start thinking about we're going to give a major release of something, maybe that's they get in that environment, they act like a authorizing official or something. I don't know. They know there's a problem, and that's that value from left to right. That's a big problem with the operational test community. They're trying to figure out what their value is in all this. Interesting times. This is based on security, but it could be anything. When you start thinking about shifting to the left, what is the value of looking at things early and continuous and making changes to things earlier than vice later? So one would assume that if I find problems later in the process, it's going to cost me a lot more to go fix it, right? I have to go back and I have to open and I got to do all this other stuff. It's pretty painful and costly. That's the problem with waterfall, right? It's if you don't get it right, it's painful and timely from a cost and time perspective. It's very ugly to where you just say, okay, uncle, and you just move forward with all the defects. If I can find it early, the assumption is the farther left I can push it, the less cost and time overall that I'm basically going to have if I find problems early. So what's the first thing that the budget people want to do when they hear this? The cost estimators, what's the first thing they want to do?
Save money.
Yeah, they want to say it's going to cost less. Do not let cost estimators say just because you're doing DevSecOps that it's going to cost less. That's not what we're trying to achieve here. The cost is not the principle. It's the time of delivery and the capability is the principle, not cost, right? It's probably a wash, right? It's going to cost you a lot more to license, to operate the software factory in a continuous mode. There is some savings in discovering early and time saving, but it basically gets consumed by other things. So when we get to the cost estimating part of the course, we'll bring this up again, but this is sort of what we need to avoid. So there it is, the principles. All right, continuous integration and continuous delivery. I said this is if you don't have it, you're not doing DevSecOps. Continuous integration, when you think about what it is, it allows Gary and other groups of Gary to integrate their code with other developers that are working on features too. So Gary's working on a feature and his team, there's another team working on another feature, another piece of code. And every night or whatever the period is, they push it back in and they try to integrate these pieces to see if the pieces work together, if they have if they're relying on each other to share information. So this is what we're talking about. That this continuous integration, at the early on go, as they first start this, there's not going to be much of a product being integrated, but they try and it goes through scans and stuff. But that's sort of where we go on this. Continuous delivery, it takes the code and builds it to a deployable state. It puts all of the security stuff in it. It's ready to go at any time that the user wants it. Okay. So when I say continuous delivery, it doesn't mean that I'm going to push it to the user. Okay. It means that it is in a ready state, that it's ready to go. Okay. That makes sense. A lot of people get confused on this. They're like, continuous integration, continuous delivery. Delivery means that we're going to continuously deliver capability to the user. It's just going to be chaos. No, no, no. We're talking continuous integration, continuous delivery into the production line. And then we say, from a management perspective, when that stuff goes. Okay, that makes sense. I mean, this is the reason we're sort of peeling this onion, because the uninformed would say, well, we'll never do that. We'll never do continuous delivery. There's no way we're going to do that. I was like, I agree with you. Maybe continuous deployment. We ain't doing continuous deployment. We're gonna stop here and make some choices on the way that we're going to be doing this. This is a representation of a DevSecOps flow process. And basically what is basically trying to show in here that it's includes all the steps to change to get the code from the developer, the coder, from Gary, to get them built with all the tools, everything that it needs in order to deploy to the customer. Okay, but we have checks and balances on this, right? We're making sure that we're doing this in a very logical, very sequential type of planning, coding, build it, get it into the release phase, get it out there when they need it, when we decide to release it, and deploy it, and then monitor it, type of stuff. So I just wanted to show you that there's these type of concepts. So it's not loosey-goosey and we're just out there, whacking away at this. We do have a process which we're following. And this is in stark contrast to how we would do it in the old days, or currently still do it in waterfall, that we basically build the code in isolation and then send it to the testers, who examine the code for security and other things, and they would log and report this stuff and then send it back to us. Right? That's like, yeah, that's not what we're doing over here. So first thing, if you think about the process, is we push the code from the source code repository. We integrate it into the application. We're basically testing it. We're doing all this automation in this. We build a complete application of what it is that we're actually going to send out there, the features or application. We test it and we deploy it, right? So we're testing as we go. But when we put it all together, we got to test it again to make sure we didn't cause any harm, right? That it's actually working the way it should work. So another automated test, maybe it's a little bit of manual testing right there too. That, is it doing what it's supposed to do? And then we deploy the application all through automation, right? It should be very little manual touching, looking, examining of the code or the features. Very little of that. And that's sort of where it goes. Let's look at the pipeline, a conceptual view of the pipeline of how I commit to building features. I actually do the feature, I build it, I test it, and I deploy it. Very similar to what we just talked about, just another way of looking at it. So this is the Gary committing the code to the source code repository. This is our continuous integration type of concept, and it's a centralized source, a centralized repository to store all the code and track versioning accurately, right? We're going to control making sure that we know exactly what's in there. The commit stage, if this is at the very beginning, it's a great opportunity at this point to make sure that the security of the code is where it needs to be. We're looking at the code as Gary is developing it. We're running scans on it to make sure that we're following best practices. So this is the early on. I have tools that will do this while Gary is doing it. I can make sure that we're compliant with whatever security best practices are. So this is automated tools, security code analysis tools are during this phase, and making sure that there's no security weaknesses. And basically making sure that every time that we check in the code, we're running these scans. Pretty impressive when you start thinking about, when we first brought up it was like, we're going to bring in the security people and we're going to sort of educate the Gary, the developers. We're going to educate them in best practice. Now I'm like, I got a bunch of tools too that I'm going to do. I'm going to run on this, make sure that we're looking at the code, this automated tool is looking at the code to make sure that there's nothing, no vulnerabilities that potentially could cause harm. Okay, so this is how you convince the ATO people that there's no way that a manual person could ever do this. We're going to start introducing the concept of orchestration. Think about, anybody been to a concert? Tiffany, have you been to a concert?
Yes, sir.
I'm not talking about like Pearl Jam or something like that. I'm talking about like a concert with people playing instruments and violins or whatever it is they do. That type of concert, band.
I've been to a few. Yes, I actually do like classical music.
Yeah. Okay. So so if you say, okay, here's the sheet of music, go play. How does the orchestra sound at that point?
I mean, they would have to stay on beat with something that they already know, like a metronome.
Yeah.
They don't have the conductor.
Well, yeah. So the conductor, right? The conductor is a very important part, an orchestrator of the entire sound that's coming out, right? But an orchestrator is, think of it from a software perspective, an orchestrator is basically making sure all these components work together like they're supposed to. So we train the orchestrator to achieve the functions that we want it to happen. So when we start talking about orchestration tools, that's what we're talking about. Software orchestrator that is basically making sure the software factory has the right type of flow. It's keeping the beat. I like the metronome. Yeah. So that's what we're talking about. So even within the software factory, we're having because we have all these tools out there, right, that do things. An orchestrator, a piece of software, basically Kubernetes, is going to be trained on what the software factory configuration is and what tools need to be run when we go through this process. So that's sort of how it works. I know this is we're at the 40,000 foot level on this, but we're going to talk more about this. In microservice orchestration, when we actually, if we're going to deploy it as a microservice and not a monolith, we have to have an orchestrator also that is doing this to show, that's basically says, this is how we orchestrate track management. This is how we orchestrate weapon engagement. This is how we orchestrate. So this, you can start saying, wow, so there's a little bit of overhead here using microservices. Remember we said monoliths are very efficient, and they basically, because they're all compact, everything is inside of it and it does its thing. When you start doing containers and microservices, when you split this apart, you have to have something over top of it, making sure it works like it should. So that's sort of the downside of this, of splitting this all apart. You have to have some piece of software that is orchestrating it. Okay, but this is the early introduction to this. You're going to hear Nicholas Chalon talk about this in quite detail, but that's what he's talking about. And so the orchestrator in the software factory is configured to reject or flag potential issues earlier and don't introduce these vulnerabilities into the code base. Okay. Yeah, do it earlier. Identifying earlier in the commit phase is the shift left principle. So let's go to the build. So I've committed to this. I know I'm going to build this. I'm coding it. The build stage basically takes when the code is committed and we push it forward through the continuous integration, continuous development pipeline. I take this stuff, this newly committed code, and I try to integrate it with existing code or other code that it has to rely on as it's going through here. So the build stage is probably going to be pretty unsuccessful at the early part of the development, right? We do this continuously where we basically put the code in. It is what it is. Gary says, I'm not done. It's like, yeah, Gary, I know. just push it in. Whatever you got, just put it in and let it see what happens. All right, we're going to get a bunch of non-build type of stuff, but eventually you'll see it starting to come together. The build phase, as we go through here, if there's dependencies or libraries that the code needs, it'll start connecting those things together. It will build Gary's software with whatever other things that software needs. It does it in an automated fashion to a final product. And it produces, ultimately at the end of a build phase, it completes a final product. It is what it is. It's tested and it's ready to be deployed if you want to. All right, that's what build gives you. And it includes all of the security tools built into the product. So just believe me right now that we're going to build in security tools that are going to monitor the software and making sure that it's capable to do what it needs to do in a cyber environment. We're scanning for vulnerabilities here again. This is another opportunity to take a look at this thing from a holistic perspective and make sure the code is secure. Test. We've been doing testing all along, right? We test for vulnerabilities and everything. Now, as I build this thing together as a package, I got to make sure the package is doing what it needs to do. And so I do automated testing of the compiled system. I'm basically identifying vulnerabilities. I'm using automated test tools to simulate attacks in a way that an external adversary would try to attack our software to breach the application. That's awesome, right? We talked a little bit last week when we talked about cybersecurity. You said, well, we're going to do these tabletop exercises. We're going to do red team, blue team stuff. I'm saying I'm doing this stuff automated within the pipeline itself. And if there's anything identified, I can correct it at this point, right? So when I say DevSecOps and when sec is security is the important part, we're doing it in spades, and we're doing it automated faster than anyone could possibly ever get it through there. Deploy stage is it's the stage at which the code is available if I decide to push it to the users, and this is part of that discussion of A/B testing, A/B development, deployment. A like alpha, B. So I'm going to give it to a small set of users to make sure that I'm not just killing myself by giving it to everybody and then have it fail. I'm going to give it to some users. I'm going to watch them use it. I'm going to monitor it. I'm going to see if it performs well. And if I'm satisfied with it, then I'll deploy it to everybody. It's right. I'm doing things. I'm going to make manual decisions on how I'm going to deploy this, but it through the software factory, it's ready when it's ready. You know, it's on you to figure out how you're going to deploy it. I'm scanning it continuously during production for vulnerabilities, and once I give it to them, I want to make sure that I'm able to monitor it. So that's sort of how that goes. Here's I think the rest of the slide deck is just some examples of processes, right? There's no standard template. This is like, okay, we're going to do it this way. No, this is just examples of how we deploy security controls within a DevSecOps environment. And there's a degree of training that I'm going to do. I'm going to train these Garys, the software engineers, the coders on best practices, right? I'm going to do that. I'm going to design my software to be secure by design. And I'm going to have basically a sign-off saying you've done all the possible security measures that need to be done on this, and someone's going to sign off and say, "Yay, verily, this looks good," right? This is part of the design phase, the planning phase. How am I actually going to protect this stuff? So this is how we're going to do it. And then you'll see a bunch of automation happening within the software factory. These tools that basically are doing the stuff they need to do, and then have a security review, and basically making sure this is the red team stuff, this is the penetration testing to make sure that we stop here and think about that the security looks like it should look like, and that's okay, right? We can stop there. More automation all the way through the steps to go out. And here you're looking at a concept of once it's ready to go, and I decide to release it, it goes, and it's automated, right? It basically goes through. I just got an alert on my phone saying, hey, the next version of iOS is available. Do you want to stop what you're doing and install this? Because this is going to take down your system while you do it. I mean, if someone is at the tactical edge and I'm going to interfere with the operations of that software that exists, I may want to ask them, you may want to not do that until you're ready to do it, and go dark for maybe a little bit of time while it resets itself. Okay, so this is what we're talking about. It's just an example. And another example of security and a type of tools that you would use. So I've been talking about all these automated tools. Here, when you it goes through the phases of doing analysis, local analysis and development, and all the things that you would build out through the software. Here are some of the tools. So Docker is a security tool, automated tool. It does it's automated. It does it in isolation. It's not connected to anything else. Just looking at that code. You go through the Git software system. It looks at the code itself. It's looking for validation. It also allows for collaboration. So allows the teams basically to collaborate if they're something's going wrong. And then another automated tester as it goes through. When we start building this continuous integration and development, this is as we start looking at Jenkins tool. You got other ones in there. AWS has one, Azure has one. You pick the best one, whatever you want. That's what it says. It's like, okay, pick what you want. And another, as you go into the tools of the deployment environment, more data encryption and security protocols are added. And then infrastructure security. This is the making sure that the software factory is secure, making sure there's no intrusions within the software factory. Pretty important thing. Tools and processes here again. All these other things. It's interesting because this is a commercial thing, secrets management, right? In industry, if you lose the special sauce of your software, if an adversary, if a competitor is able to figure out what you're doing, then that's maybe not the best thing for you. So if you have secrets, we're not talking about classification. In our case, we could be talking about classification. It's interesting. I'm gonna push through this. I only have a couple more slides, and we'll let you out early if that's okay with you. So when I was when I was a program manager for ship signal exploitation equipment, Increment F, it's a SIGINT system that we put on ships to what SIGINT does, and it is top secret SCI program. And I went to the contractor who was building the system at the time was in Fair Lakes, Virginia. It's just right outside DC, outside Dulles Airport, in that area, if you can imagine. And they had a big building, and they were building the hardware there. They were putting together. We were doing the DT testing and stuff. And I said, well, where's the software on this? Where, I didn't realize this was a software intensive program, but this was 2005, 2006 timeframe, 20 years ago. I didn't realize this was a software intensive system. I said, where's the software being built, right? They're doing a service oriented architecture. I said, where's the coders on this? And they're like, well, they're in the Hyatt next door. I was like, you're developing my top secret SCI software at the Hyatt? They're like, yeah, we got like 20 some coders from India. They're being housed in the Hyatt, and they're coding the software. But it's unclassified software, right? It's just the operating system. What could go wrong? Now, fast forward to today, as we start thinking about zero trust, we start thinking about malicious code, backdoors, all this other stuff. It's like here I have my my principal operating system, these coders from India that are not vetted, not checked, basically building a top secret system in an unclassified environment. Yeah. This is what it looks like from a I know. DoD Enterprise DevSec technology stack. So this is from the DoD. This is how they view it, and here are the tools that they recommend to use in DevSecOps. And things should start looking familiar, right? We're going to plan and we're going to develop the software, the capabilities, the features. Here are the tools that they basically recommend. Jira, Git, of course, and GitLab. These are tools that you can use to do automated testing and add value in the management side of things. We start building it, right? This is Gary coding it, building it. We're doing continuous integration, continuous delivery. We're doing all this stuff. It's going through this process, but here are the tools. And you can read these as well as I can, nothing in particular, but these are the tools, the automated tools that can be used to help build and test the software as Gary's developing it on a daily basis as it comes in. When we get this thing all together, we build this and say, hey, here's the package of stuff I want to give to the user. This is the build with all the features or feature. I need to test it as a unit, and here are the tools that basically are there. Once I test it, I'm going to run another security scan on it to make sure that it actually functions. I'm going to try to attack it and see how it responds. I'm going to do that in that environment here, and here's all these tools, bunch of commercial tools. These are all commercial, right? DoD didn't spend $1 to produce these. And then when I store the artifacts, I need to make sure that I encrypt them. I gotta store them in a safe spot. That way, when I want to reuse them, or if somebody else wants to reuse them, and I have this in a repository that's open to the DoD, all they have to do is pull that chunk out. It says, you guys have already done that in the DoD. I'm just going to reuse that artifact, that thing. And that's the power of Platform One. Of here there one Cloud One, all this other stuff that we're doing over. So here's the continuous integration, continuous delivery orchestration. And so Kubernetes is what we use in the software factory to orchestrate all this, to make sure all the tools are working in the right order. We also use Kubernetes in the delivery of the software when it's operating in a microservice environment at the user's location. You'll hear Nicholas Chalon talk about don't lock in. He's very worried about tools and not getting a proprietary tool that goons everything up, that you're stuck using that tool. He said we should buy the license. It should be universally available. And if I use Jira one time and Jira basically they have some sort of process in which they're doing something and it locks us in, then we stop using Jira. That's sort of when he says in his videos, when you get to it in 2 weeks, he'll be talking about don't lock in, making sure that we don't have proprietary stuff in there that basically causes us that problem. So as we start thinking about how do we deploy and operate our software, this is the continuous delivery, when we want to deploy it and monitor, and then the scaling of it. So this is the DoD vision of the technology stack as an example of it. So this is documented. So this is the DoD vision of how you do all this stuff. Okay, looks pretty interesting, right? I mean, it's very complicated when you first look at it, and then you're like, oh, okay. So we're following process. We're using a bunch of tools that automate and make it go faster. We're collaborating with each other. We're talking to each other. The user is involved. They are a willing participant in all this, and we're monitoring the software as it's being used out there. So let's go do that. And that's sort of where we're at. A couple more slides. It is just just a vision of How do you improve faster delivery, blah, blah, blah. This is just their little slide. How you can reduce cost, how you can improve security. We all believe that, I think, at this point. I like this chart, and we got one more after this. This sort of describes how waterfall works. And if somebody says, I don't understand the difference between waterfall and DevOps, I don't understand the value. What are you actually talking about? So you should be able to say, hey, it's like, look, we go do this, we get these detailed requirements, we do all this detailed planning, we do all this detailed coding, and then we do all this detailed testing, and then we have some sort of security review of this, and then we release it out to the user, and hopefully nothing goes wrong. If it does, then if something goes wrong in here, then the code has to be fixed and everything. So it's this very linear, very waterfall-like. You do this, and then you do that. You do this. Not a lot of interaction between the developer, the testers, the security people, or the people that are going to use it. Not a lot of connection. You know the value of waterfall when it's appropriate. If you know everything and this is okay, then go do that. This is simple. You can understand this. When I start talking about DevOps or DevSecOps, I'm like, I'm going to do continuous planning, continuous coding as we go along. I'm embedding in security with automated testing, best practices. We're communicating between all of the disciplines. I'm doing continuous testing. Ultimately, with the final product that I'm going to give the user, I'm going to give it to them in production, and I'm going to get feedback all the way back to the beginning of planning and coding. To what have we learned? What are all these other mechanisms? So, you know, quality and security risk is managed by rapidly releasing of fixes. Today, if I do waterfall, if I find out there's a security problem or I didn't exactly get it right, it's going to be years before I come back with a correction. You've seen this in our processes. When DevSecOps or in DevOps, we're talking about if we identify something is wrong at the user end, some sort of security problem, if we missed it all, we can easily come back through quickly and release a fix to that particular application that has some sort of security problem, right? Because it's not a monolith. It's not, as one of my thesis students saying, it's not spaghetti code, right? It's like if you touch one thing, you break 5 other things. That's not how we're designing it and developing it. It's individual capability as it goes through. So waterfall is biased to plan and quality. I mean, they say weeks and months. We know that's not true in DoD. Where DevSecOps and DevOps is biased to speed and agility. I can get this out there with a quality product in a matter of hours if that's what I wanted to do. Okay. Last slide here, and then we're done. This is a chart that basically says where could an attack happen. That we chatted a little bit last week about supply chain attack, and I told you I was a little bit worried about we're using these commercial tools, and I mentioned SolarWinds as a commercial product, and it was attacked, a supply chain attack. And then basically as people were using SolarWinds, it infected their systems. It transferred the vulnerability into the systems that were using it. We got to think about that. We need to design our software factory to be self-aware. I don't know how to, it's like almost like AI in a way. We have to make sure that we do our infrastructure as code. You'll hear Nicholas Shalom talk about this. He's basically saying our software infrastructure needs to be monitored. We need to make sure that if we're using a tool, that we're monitoring that tool and we kill it on a regular basis to make sure that it's not been infected or whatever. And what that means is, we have the security tool, we're using it, and the next day we basically we bring it down and kill it, and then open up a new instance, a new fresh version of it. He says these are all it's the randomness prevents an attack. If somebody's already infiltrated our software factory and has gotten into it by killing these applications and bringing them up fresh, then they have to start over to try to penetrate. So you're going to hear more about this stuff as we go through this, but it is very concerning if we're going to use commercial products. You know, how do we use commercial products today? Does anybody know? If you want to use a commercial product on a network, what has to happen? Lewis, what has to happen?
So it has to be approved first before it can go on a net, unless you're operating in a private net that's not connected to the DoD IN.
Yeah, it has to be approved. And usually how it's approved is somebody's looking at the code or looking at the system, make sure there's no nefarious things that are happening. It's not doing something that's going to cause a vulnerability, right? So that's the reason it takes us so long to get the next version of Microsoft Office or Microsoft Word or the operating system. This is why it takes so long. So I think they just approved for the Apple computers, the next version of iOS that was released 3 years ago, right? Is some NSA organization or somebody is looking at this commercial product to make sure it's good to go. For many years, you couldn't use one of these smartphones. They're like, oh no, you can't do email on that. You can't do government email. We don't trust this. You know, it was BlackBerry back in the day. But that's what we're talking about. We're talking about if we're gonna leverage the commercial marketplace and we don't control it, when there's a new version of the tool, we need to understand the risk of it, and we need to make sure that our software factory is able to use that newest version when it's ready to be used. We're just not going to go pull it off of the dark web and start using it. Okay, I just want to point that out, that we are thinking about this, and it's part of our design of our software factory to make sure that it's able to use all these commercial products and understand the supply chain vulnerability stuff.